So I'm pretty sure that on my previous video about my interpretation of general relativity is going to be misunderstood, because I know from experience, because I've kind of tried explaining my ideas to people before. I know the things that people are gonna say, like, oh no, this is blah 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 blah. Yeah, like one being that there is no preferred reference frame in space time. That is true. I don't actually disagree with that. So the gist of my idea isn't that there's a preferred reference frame, but it is that there is an ultimate overarching space and there is an ultimate overarching time, and that these are distinct from space-time. The space component of space-time is measurable distances. The time component of space-time is measurable durations of time. And these are both mutable based on velocity and acceleration. I do not dispute this in any way whatsoever. So a meter is, we think of it as a unit of distance in space. I am, very strictly speaking, I'm actually going to have to disagree with that. Under my analysis, no, it is a measurable distance. And that's it. It's a measurable distance. And this actually agrees with the mathematics of both of the relativities. But I think more of interest is general relativity. It's the one that fucks with shit the most. But both of the relativities, right? Something moving relative to you, you're gonna get these weird length contraction effects. And somehow that grew into string theory in a way that I don't even understand, because the length contraction only takes effect for things moving relative to you, not your own reference frame. I don't get it. I don't get how that's supposed to work, but whatever. Yeah. I don't agree with string theory but I also don't understand it fully. So I'm not really in a position to be like, yeah. What I am in a position to be like is say, I don't get it. The parts I think I get don't make sense. So not a fan. Not on board with that shit. Yeah, so the problem with like a meter or a foot or an inch or a kilometer or a light year, or right, the distance, right, units of distance, is it's not really, and we know this. General relativity tells us this, right? So within your reference frame, a meter is something like that. But if you are traveling at close to the speed of light, a meter is a lot longer. It's a much further distance. Except that it's also a much shorter distance. It depends. It depends on who's doing the measurement. It depends on what you're looking at, where you're at, and all kinds of crazy shit. Like, a meter isn't a thing. It's not a real thing. It's not a distance. Right, so it's not it is, but it isn't. It's a measurable distance. And because we're subject to the effects of the relativities, it's not actually a distance in space. It's a distance in space-time. And the Lorentz transformations alter these, like they mess with it, and they also mess with time, right? So a second isn't actually a unit of time; it's a unit of measurable time, right? So space time is about measuring space and measuring time. It's not actually about space or time. So space, there is no reference frame that can see space. There is no reference frame that can see time, that has access to it, that can measure it. You can't measure a meter in space. You can only measure a meter in space-time. And depending on the behavior of your reference frame relative to other reference frames, you're going to get correspondingly weird numbers, your weird results, weird, yeah, I don't dispute that in any way whatsoever. I'm not claiming that there is a preferred reference frame. And that has been a sticking point for a lot of people when I'm like, I think I have an argument for, like, there's an ultimate time, there's an ultimate space. It is not a reference frame. They are not accessible to measurement. Because a meter within this ultimate space is meaningless. It can be any length, really. But as far as the reference frame operating within the space-time field that permeates space, it does mean something. And that's the only thing that we really have access to. That's the only way we can make a measurement, is by making a measurable measurement using measurable units. That's the only thing we can do. The only measurements we can take are measurable measurements. Right? But this entire thing, for relativities to work, for this entire framework to even be possible, I think there has to be an overarching space, an overarching time, whatever. Like, those are bad names for it, but they're also the best names for it. It's terrible. It's terrible. Yeah. So, in my view, the ultimate uber space doesn't, like, meter doesn't mean anything. Mile doesn't mean anything. It doesn't operate that way. You can't measure things. You can't measure distances. They exist, but you can't access them. And time operates exactly the same way. Right? So, within space-time, under very extreme conditions, time turns into space. Or space turns into time. Right, you get these just really weird effects. That makes perfect sense, actually, once you have uber space. And you can look at it kind of from, like, a sort of an outside perspective, and you're like, I know exactly what's happening here. That makes perfect sense. But if you can't conceptualize the uber space, it's just fucking weird. And, like, the math tells you it's there, but it's really counterintuitive, and it makes absolutely no fucking sense. When you access the uber space, it makes sense. It's the only way it makes sense. When you can look at from the uber space and the uber time. You made up these terms. I don't fucking know. Because space and time, they're kind of already taken, and it's... Yeah! Bad. Space-time is a fantastic name for the gravitational field. Yeah, I'm not going to contest that. It actually is. It's a really good term for that. But it's confusing because space-time is neither space nor time. It's describing the measurability of space and the measurability of time. And there are circumstances under which time is not measurable. And there are circumstances wherein distance is not measurable. And they become each other. And like that does not make sense in a sort of Euclidean space. But it does make sense if you have a Euclidean space and within it you have a gravitational field. And there's just a few specific properties of this gravitational field and of things that are operating within it. And then it makes complete perfect sense. Also, that's how the math works. Because you automatically get Euclidean, like Cartesian sorts of coordinates as soon as you're counting. Right? 1, 2, 3, 4, 5, 6. If you're measuring stuff with numbers, you're automatically dropped into a Euclidean sort of, a Cartesian sort of space. A Hilbert space. However you want to describe it.
Let's worry about the number of dimensions and change the name accordingly.
Whatever. Yeah, so you've got the direction of motion. Okay, that's one dimension. And you've got like this horizontal direction perpendicular to it, and you've got this vertical direction, right? And really only the direction of motion is subject to Lorentz contraction. Okay. That's fine. That's fine. So you have 3 directions, and what was I fucking talking about? Yeah, those are measurable. Those are your measurable distances, but they're not real. They're not, that's not, I don't know, they are, but they're not. That's not space. And the fact that it's relative to the behavior of your reference frame, to the acceleration that your reference frame is subject to, or to this velocity that relative to other reference frames that your reference frame is subject to. The fact that it's relative tells us that this isn't really space. Tells us that this isn't really time. Because it's weird to say it this way, and I understand that it's confusing, but within the time that these two different reference frames experience different amounts of time, that amount, an amount of time passed. An amount of Uber time passed. This guy experienced 2 minutes, this guy experienced 4 minutes, but it was within the same time, the same amount of Uber time. The Uber time isn't measurable, there's no reference frame that can access that. But they both, whatever happened to them happened within that Uber time. I don't see how that's an escapable conclusion. There's no way you can get away from that. But you end up with this problem because Uber time doesn't operate in seconds. It doesn't operate in minutes. It doesn't operate in years. It doesn't operate in hours. It doesn't, right? Measurable time cannot get you to Uber time. So it's this weird, we think of time in these terms, but that's not what time is. That's actually an aspect of space-time. Which is really, that's a real mindfuck, I think, right there. It's kind of amazing. And I do think, from what I've seen, that is distinct from other claims of an ultimate overarching space and time. I think Lorentz himself was even sort of keen on an idea sort of like this, except that it was a preferred reference frame, and that can't work. No, there can't be a preferred reference frame. So, for instance, a thing that I mentioned in my other video, is that if you are moving through space, you're going to be experiencing time a little bit differently than if you're completely stopped within a parcel of space, right? So we know that parcels of space are moving relative to each other, and objects within those parcels of space can thus be stationary relative to the space around them, and yet still move away from each other. And this has to be the effect. It actually has to be that they are stationary or relatively stationary within their parcels of space, and it is the parcels of space that are moving, because via this effect of space, parcels of space moving, you can achieve velocities, relative velocities that exceed the speed of light. So it's not that the object is moving through space. It can't be, because the objects cannot move through space faster than the speed of light. There has to be, space has to be a thing. It's not material. It's not energy. It's not matter. It's not like a thing like me, but there's something there. So, kind of like the old concept of ether. It's sort of like that. Like, that idea was sort of accurate. The mistake, I think, the big mistake with that one is it was assumed to be a material, like, a physical material. It kind of is, but it's not. It's not this sort of. It's not. It's not this sort of energy or material that we're made out of. But it is. It's sort of a thing. It's the thing that holds fields like electromagnetism and Higgs and gravity and strong nuclear force, like these fields that the interactions are manifestations of. And so a parcel of space, that's a real thing. It's not an imaginary, purely conceptual thing. A box of space is a box of something. There's stuff there. It's not molecules. It's not atoms. It's not electrons. But it's a thing. There's something there, and this can move. It can move, and it has a speed and material energy within it that's operating within it has speed relative to it, and the maximum speed that you can move relative to it within it is the speed of light. That's what that is. It's the propagation speed within this substance of sorts. Yeah, so if you can move relative to it at some maximum speed, and if it moves relative to other things, like if it's real, then there is a speed that it moves at. There's a speed that it is moving at, and you can match that speed. You can stop relative to the parcel of space that you're within. Now that reference frame, it's quasi-preferred. And what I mean by that is you can't ever actually find it after the universe has kicked off. Once you're in a state of the universe where particles exist and like you can actually do something, it's too late to ever find this exact state. And the main reason I think. I should probably fucking wrong about this, but the main reason is that acceleration jacks up your sense of time and distance. It messes with your space time. So, in such a way that it's not actually ever possible to determine what stopped is. You can get close, but frankly, we're probably already close. Like any material that's just kind of chilling out in the universe is probably close to stopped relative to its parcel of space that it lives in. Especially billions of years out. We're probably pretty comfortable at a pretty low speed relative to the space around us as far as ordinary objects are going. So, the accelerations. So say say this is Earth, right? And you send one thing this way, it accelerates this way, and then stops, and you measure how time passes there. And something else comes this way, stops, and you measure how time is passing there. They're not going to see a difference. They're not going to see a difference. It's too late. The only way that you could see this difference is if you had a clock going already when the Big Bang happened, which is absolutely impossible, and it survived the Big Bang, and it was always tied to a parcel of space as a case. So like the Big Bang occurs, and this little clock is recording how time is operating the whole while. That is the only thing that is going to record actual time. Uber time. That's the only thing that can access that, or very closely approximate accessing that. And that's absolutely impossible. That's not a thing that you could do. So, yeah, I don't disagree that there is no preferred reference frame. I do not disagree with that. I absolutely agree with that. All of the predictions of the relativities I agree with. I don't have a problem with the predictions of relativity. I have a problem with the interpretation of relativity. That's not something that you see very often, right? You see that with quantum mechanics. Like, people disagree with interpretations of quantum mechanics, but pretty much people don't disagree ever with interpretations of the relativities. So, that's how much I have wasted my life thinking about this bullshit. That I've actually come to a contentious interpretation of relativity, general relativity and special relativity. I'm probably wrong. I concede that 100% because, yeah, but we're the general consensus is definitely wrong, right? Because it fails. It fails in a few regards. We know this. That is not contentious. That the fact that there are failures is not even debated. What those failures mean is what's debated. Where you can go from there, that's what's debated. But the fact that the consensus view of how relativity works, the fact that that is broken some way, that it doesn't work somehow, that is pretty well established fact. So, yeah.